Again, we have to assume that momentum is conserved. It never is completely, but we can come close. And we will have two cars that, no, we're going now completely inelastic. Completely inelastic. So they hit each other and they get stuck. I get a certain velocity which I put into the first car. It hits the second car and it gets stuck. And I see there what my V prime is. I see there on the blackboard that if the two are the same, I have a 1 here, a 1 and a 1 here, if that's the ratio. So the outcome is that V prime must be 1/2 V1. So this must be 1/2 V1. Now I have a mass which is half the other one. I plow it into the other, they get stuck together, and now I get 1 divided by 1 plus 2, I get 1/3. Notice in both cases I get a plus sign. That's of course obvious. If I plow into something and they stick together, they continue in the same direction. And so now I will do the timing in exactly the same way that I did before, except that now I have a completely inelastic collision. I will have a timing T1, and I will have a timing T prime. The cars have a slightly different mass, 237. Plus or minus 1 gram, and I have one that is 474, plus or minus 1 gram. Not too different from this. I have 2 of these cars, and I have 1 of these. And first I'm going to slam these 2 onto each other, and so when they collide, I expect the speed to be half, so I get a certain amount of T1. So T1, T prime will be twice as long because the speed goes down by a factor of 2. So when I multiply this number by 1/2, I would like to get that number back. Here I get the time for this car. The first one to come in gives me a certain time. When they continue together, the speed is 3 times lower, so this time will be 3 times higher. So I multiply this by 1/3. And I would like to get that time back. And those are the 2 experiments that I would like to do now. So we have to get the noise back on. Air track 1, air track 2. Here we have the 2 cars. They have Velcro. So when they hit each other, they get stuck. Sometimes they bounce actually. You have to do the experiment again. This one goes here. This one goes here. Are these 2 timers on? We don't need this timer anymore. Are they both on? 0 them. 0 them. Are they 0? Okay, you ready? This one is going to plow into this one. They merge and they continue, and then you'll see the time T prime here. There we go. Ready? All right. What do we see? 1, 3, 8, 2, 8, 8. 1, 3, 8, 2, 8, 8. 1, 3, 8. 2, 8, 8. Divide this by 2 is 0.144. That is, the difference is only 6. And that is only 4% off. That's completely within my prediction that each time could be off by 2.5%. Now I will have a car which is twice the mass, and this is once the mass. I will set them again to 0, and now we get 1 onto double the mass. We ready? There we go. Oh, you see they bounced. They didn't stick. So we have to start all over. If they don't stick, of course, then it's not a completely inelastic collision. There we go. They made a slight bounce, which I didn't like. Let's see what we get. You can always do it again. 168, 545. 168. Multiply this by 3. 504, 545. 8% difference is a little high. But these things can happen. I told you they bounced. I didn't like that. And then they got stuck again. I will do it once more. Maybe I'm a little bit luckier. Again, they bounced a little before they finally merged. 603, 187. (187), 603. If I divide this by 3, I get 0.201. And that is off again by about 13 units, about 7% difference. So it's a little bit more than the 5% that I allowed for. Now